So this problem is a little bit lengthier. I already done. I want to explain the steps. So let A be 1 by square root of x plus ib and A dagger 1 by root of x minus ib be the lowering and rising operator of a simple harmonic oscillator in unit where the mass and angular frequency and HR have been said to be unity. So if 0 is the ground state of a oscillator and lambda is complex constants, the expectation value in the state. The psi is given exponential of lambda A dagger minus lambda star A. A and A dagger are rising lowering operator, 0 is. For solving this kind of problem, we need BCH relations. So the BCH relation tells us A and B are operators. This relation you can, using the Taylor series, you can expand this as B plus A commutation B 1 by 2 A commutation B. It will go up to infinity. Now you want to find the psi xi star because they are asking expectation value in the state psi. So the expectation value in the state psi of x. So take psi xi. We know what is psi. So if you are taking left hand side, take the complex conjugate of this operator. So exponential of lambda star a minus lambda a dagger. Then if you are doing simple algebra, you will get what is your x. If you are adding these two, you will get a plus a dagger by 2 is equal to x. That x value I substituted here. This is the x value into the ket. So this ket psi is exponential of lambda a dagger minus lambda star a 0. Now we can break this totalization into two. One is first with the annihilation operator plus with the creation operator. I multiply inside this left and right bracket each and every operator. So I am keeping this a. I multiplied ket and then bra. Same I kept a dagger here. Then I multiplied ket and then bra into 1 by root 2. I am taken out of it. So I'm taken the first one is this relation we got to solve. The next second is this relation we got to solve. Before solving, we got to identify one relation. So suppose if the exponential having the operator lambda star e minus lambda a dagger. This relations, you know, the operator e to the power a plus b should be equal to e power a, e power b, e power 1 by 2 a commutation b. Same rule if you are applying here, you will get exponential lambda star a, exponential of minus lambda a dagger. Exponential of the commutation will give plus lambda square by 2 for the first one because lambda is a complex constant. Same way if you are doing second relation, you will get here final exponential of minus lambda square by 2. So these two relation we need, then BCH formula. If you know these three relation, this problem is simple. Now come to our first term. So take the whole term, first term from here to here. I took the whole first term. See the center relation, it is exactly looking like BCH relations. Here a in the position a, lambda star lambda a dagger will be there. In the position b a the annihilation operator will be there. Just I am expanding these three relations as BCH here. So using this relation we will get a minus ba. So that is lambda a dagger comma a plus it will give lot of commutations. No need of worry because the second commutations afterwards it will goes to 0. The second commutation here I am writing here. If you see the second commutation, the BCH relation a comma b, here in the position a we are having lambda a dagger. So lambda a dagger, so lambda a dagger comma a. If you are doing inside computation, it will give the answer minus lambda. Then if you are doing outside, already constants, complex constants, some complex number, For doing computation, the second computation goes to 0. That's why the higher order computation always will give 0, just to keep up to the lower first order, up to the computation in the BCH relation, up to this order is enough. Because the higher order obviously goes to 0. This will give the constant, complex constant value. If you are taking computation with A, then it will goes to 0. So then I'm writing this into, breaking this relation into 2 with a negation operator, the given answer, then multiplying bracket inside, then already here minus a dagger a, it will give plus. So plus 0 exponential lambda a bracket. This a dagger a will give plus lambda I am taking outside. So this value is nothing but 1 exponential of 0, it will goes to 7 bracket. Actually I am missing lambda here. Here it will come lambda. If you see the first relations, a, here a, both three of them are annihilation operator. If you are using the BCH, you will get a, other computation, all the computation will goes to 0. But this a, the BCH first answer a is sitting, but here ground state. If the annihilation is operating on the ground state, the answer goes to 0. So 0 plus lambda, finally we will get lambda. So the first relation is easy. Now come to the second relation. I am writing other side, the whole relation, the second relation. If I see the first relation, take the center to value, the e to the power minus lambda a dagger, e to the power lambda a dagger. This relation, all the operators are creation operator. So from the second commutation itself is 0. That means all the commutation will goes to 0. Only the a dagger will come. If you are expanding using BCH relation, Becker-Campbell and Hausdorff's relations, you can read what is the relation. You can derive this relation also. Using that relation, you will get a dagger. Now multiply with the bracket with this a dagger, you will get this answer. Again use the BCH relation one time. B a plus lambda star a comma a dagger. Then you know, for annihilation creation, if two operators are mixing, from the second commutation it goes to 0. You can stop up to first commutations. So if you are using creation operator, just to multiply bracket a on either side. So a dagger, if it is operating, it will trace on state, but 1 0 it goes to 0. So the first relation goes to 0. The second relation will give a dagger plus 1, lambda star is outside, take the outside. So 0 0, it will give the, actually if you are expanding one more step, 0 a dagger, I am expanding the whole relation, 0 plus 0, the first term. I can take lambda star outside, commutation a comma a dagger plus 0, just an expansion of the previous step. This anyway a dagger, if it is operating, it will rise state 1, but 0 1 it will go orthogonal state, it goes to 0. So a dagger already you know 1, 0 into 0 1, the bracket relation, because both are the normal states. So final answer you will get lambda star. So this is the sum relations. Now sum these two relations outside 1 by root 2 factor is already told. The 1 by root 2 factor is sitting. This is the first relation. This is the second relations. So sum these two, multiply with 1 by root 2. You will get 1 by square root of 2 lambda plus lambda star. So the given option is 4.